So we are going to look at chapter 10. This is about the correlation and the regression studies on two variables. Now here we are going to look at the linear relationship between two variables. Okay. So always we will have a independent variable and the dependent variable. I think we have discussed these things in chapter 3, I believe, the relationship between two variables, right? So normally, in general, we take x coordinate as our independent variable and the dependent variable as our y coordinate or y variable. Normally, we pick these two. Okay. So if you are given a data set, so we could, find the relationship between those two variables by looking at our data set. So if you draw a picture for those data values, which is called the scatter plot, okay. So if you look at these kind of plots, you see that a lot of points here. These all our data points, right? So if you look at the first picture, let me change my color. Okay, so if you look at my first picture, all the data points has the the trend of moving this direction, right? So there's a relationship between all the points, like moving on the straight line. So, but in positive sense. So this is called a positive linear relationship. So if you look at these data values for the second picture, so all the points linear, but going downwards. So this is called the negative linear. But if you look at number 3 picture, all the data points has kind of relationship, but not linear. But if you approximate this all like a curve, right? But anyway, we have the relationship, but in terms of some curve, so which is called a curvilinear relationship. And if all the data points, have kind of scattered everywhere, so no relationship between points, this kind of, the relationship are called a no relationship actually. So it is scattered, randomly scattered. Okay. So now in this section, we are interested in looking at whether they have the linear relationship or not, right? So before going to do that, let's look at how to, draw a scatter plot. So normally scatter plot we draw for the given data points. So you'll be given data points. Okay. So the data points will be given. So by using the data points, you need to look at the two variables x and y, and you need to, each point will have a two coordinates actually, right? So it will have a two coordinates. So basically x and y. Then we will plot those values here, and if you look at that picture, it is called the scatter plot. Okay. After drawing the scatter plot, we could check whether they have a linear relationship or not. Okay, so typically you will have two values, right? So look at this data set. This is the given data set. So there are a lot of companies, 1, 2, 3, 4, 5, 6. There are 6 companies. They are, the production numbers of cars and the revenue is given in the table. So now we are going to look at, is there any relationship among these companies, right? With the production and the revenue. So if you draw a picture for this, you will have like this scatter. If you look at how many points I have here, 1, 2, 3, 4, 5, 6. That means you will have 6 data points. Yes, 1, 2, 3, 4, 5, 6. You will have 6 data points. Okay. So now my x coordinate is they have picked this as x coordinate, and the revenue is in my y coordinate, right? So the maximum value for my x values, you see here it is 63, right? So we take maximum 63 among x and among y. The maximum you see here is it is in billions. Oh, so it is here. So the maximum of y value is 7. So according to that, you could draw a picture and the plotting the things, right? You will have like this. Anyway, we have calculator and we could draw the scatter plots, right? So let me see how to, uh, draw these things in your calculator. Okay, so the thing is now, first you need to plug in your values x and y. So I'm taking to stat, edit, and I'm going to enter. I already have entered this. So in my L1 column, I'm entering my x coordinates, in other words, my independent variables. And my y column is L2, that is the revenue in billions, right? So first enter like that. After entering all the, the values, if you want, you could set the window first. So I'm setting my window. So if you look at your x value, maximum is 63. So if you want to, you could make here the maximum, say 70 to cover all the points, right? Okay, so x scale you could keep 10 or 5, doesn't matter. The y values, if you look at all the y values that is in my revenue, there's no negative, right? So if you want, you could make the minimum is 0, no problem with that. And the maximum, the value is 7, so let me keep that as 8. And let me leave remaining. And I need to read this. Okay, so now how do you draw the scatter plot? Going to the step plot. So second with y. Okay, so now I'm choosing plot 1 is on. So moving to plot 1, so it is already on. Now what type of graph we are looking for? We are looking for, we are looking for the scatter diagram. So this is scatter diagram. So second one is polygon and the histogram, and the remaining all we know, right? This is box plots, so and so on. So I need now scatter plot, so I'm choosing first to that. Okay, so my x values are in list 1, L1, and my y is in L2. So remaining all correct. So I'm leaving as it is. So now I need to exit from this. Okay, now let us see how our graph is. So this is my scatter graph. So if you look at this graph with the picture here, almost similar, right? So all the points, 1, 2, 3, 4, 5, 6. I have 6 points in my picture. That means I have all the points here. So you have to, set your window according to your x and y values. Okay, so this is called the scatter plot. So do you see any relationship among these data points?
Yeah, clearly company A must be Toyota.
Yeah, but among these, say it again. What's that, George?
How being funny, I said company A must be Toyota because they're outselling their competitors by a lot.
Yeah, you're correct. So you see now, that's a relationship among all the points, right? So kind of linear, right? So if you look at all the values of, so it's kind of, if you draw a picture, this all the points moving, towards this direction. So it seems like we have a positive linear relationship. Okay, but how are we going to, finalize or whether these have exactly the linear relationship? So we have, you know, one measure to check whether the data points have a linear relationship. So which is called the correlation coefficient. Okay, so we look at the correlation coefficient. So we look at correlation coefficient, we denote by little r, right? This is just a number. If you have the data point, so we could calculate this little r. That's a formula to calculate little r. Based on your r value, we could say whether they have relationship with linearity or not. Okay. But remember, these are my data points. So all the data values are coming from my sample. So this is just the sample data. Okay. Therefore, this guy is actually, the correlation coefficient for the sample. But for the population correlation coefficient, we denote that by the Greek letter rho. This is rho. Okay, we need to pronounce like rho. So you have to write like that. Okay, so rho stands for the population correlation coefficient and little r for the sample correlation coefficient, right? The linear correlation coefficient computed from the sample data measures the strength and the direction of linear relationship between two quantitative variables, x and y, you could call. So now we are going to look at, about the formulas to calculate little r. Okay. So it is very hard for us to find the population correlation coefficient. Instead, we find the sample correlation coefficient, little r. Okay. So this is the values, the possible values of our r. So our r value is always between -1 to 1. Okay. So if you see your r value very close to 1 or -1, that means we have strong linear relationship between those two variables. If little r is very close to 0, that means we don't have any linear relationship. So that is here. Okay. Based on our r value, we are going to look at. So everything is summarized here. The correlation coefficient is, unitless measure. It is just a number. There's no unit for little r. The value of r will always be between -1 to 1. If the values of x and y are interchanged, the values of r will be unchanged. So that means what? That means if you switch your independent and dependent variable, your r value is always going to be same. That's no difference. Okay. If the y values of x, sorry, if the values of x or y are converted to a different scale, the value of r is again unchanged. So you could rescale your independent or dependent variable. That means again your r will be unchanged, the same value. Okay. This value r, correlation coefficient, is very much sensitive to outliers, right? Outliers means what? If we are given so many data points, if one data is far away from that one data point is far away from some other point, then this is outlier, right? So this outlier, now give trouble when you calculate your, the correlation coefficients. That's what this is. So the value of r is sensitive to the outliers and can change dramatically of your r value. Okay. So these are the properties actually we have for the linear regression, coefficient of actually. So based on our r value, they have summarized this, right? If you look at your r, so here in this example, you have plenty of data points, right? So it seems like all the data points like a cluster, but moving around this direction. So that means it has kind of a linear relationship, right? In that case, they found that r is very close to half. Now look at my second picture. R is very close to 1, right? So that means it has a strong positive linear relationship. So it's moving positive direction, but very strong. If R is 1, that means it is exactly the linear. like a line, right? All the points are fitting on one straight line. So when if we have like this, then our correlation coefficient is 1. Now again, this all in another sense, right? Negative sense. So you have again negative half, but all the points are clustered, but moving downwards, so negative. So here again, it's very close to a 1, but going down, therefore it's negative 9.9. And again, this all again the linear, exactly the line, but going downwards, so negative. Okay? So these are just the example they have shown how the scatter plot is related with the correlation coefficient little r. Now, these are the assumptions we use for the correlation coefficient little r. The sample is random sample. Remember, to find the little r, we need to have a sample. So the sample, should be a random sample. The data pairs fall approximately on a straight line and are measured at the interval or the ratio level, right? So these are, the data pairs fall approximately on a straight line. So we assume this condition for B. Okay, so two values actually the data pairs. So we approximate that to a linear. The variables have a bivariate normal distribution. The bivariate means what? You will have two variables. If you fix one variable and the another one is going to depend on the first one, that variable is going to be the normal distributed. That's what they explain here, right? The variable have a bivariate normal distribution. This means that for given any specific value of x, right, you are fixing x, then you are looking for the distribution of y. If y is normally distributed, then which is called the bivariate normal, vice versa. So you could fix then y value, then you are looking for the x. If x is normally distributed, then it is called the bivariate. Why this word came bivariate? Because now this normal distribution is defined based on two values, right? Two variables. That is why it is called the bivariate normal distribution. Okay. So, look at this formula. This is the formula we use to calculate the sample correlation coefficient. Look at the formula, kind of complicated, right? What is here x? X is all the data independent values, and y is my data dependent value. So you will have so many, so little n is number of data points or sample size, right? Okay, so now we are going to use this formula if you want to find the correlation coefficient manually. So you have more work, okay? So first I will show you how to, use this formula manually to calculate R. After that we will move to, the calculator use to find the little r. Okay, so now let me write down here this formula in, the clear way. So the correlation coefficient is given by number of data points. You are multiplying with the sum of the product of x and y. Okay. Then you are subtracting individually the product of sum of x and the sum of y. Okay. So these two are two different things. Then after getting this answer, you are dividing this all by the square root of, right, what? N times. So you are multiplying the sum of x value square, right? Then you are subtracting the sum of x. After getting sum of x, then you are squaring. These two are different things. Okay. So these all under one parenthesis. Then for the you need to extend. Then you have the second parenthesis. Now you do the same thing for your y variable, right? Multiplying n with the, the sum of y squared, then subtracting the sum of y, then squared. Okay. So 1, 2, 2. Okay, so now this is a huge formula, right, to calculate the little r. That means what? If you look at this formula carefully, I need to know a lot of things, right? So what are those? First of all, you need to find xy's for each data point. Then you should know what? X squared for each data point. Then you should know y squared for each data point, right? So, and of course, you will be given x and y. That is why if you look at this one, right? So x and y will be given in the problem, basically coming from your data points. But once you have the data points, you need to find the xy for each point and x squared and y squared and so on. Once you have these all the values, then use the formula and find out. Okay, right. So let's look at one example. Okay, so we will do that same problem, the data points we had for the earlier example. We use the thing, right? So now these are my x values. The first column is my x value. This is my y values. How many data points I have here? I have 6 of them, right? Therefore, my little n is here 6. There are 6 companies. These are my data points, right? Okay, so look at the first data point. This is my first one. This is second, third, fourth, fifth, and sixth, right? So this is my x value for the first data point, and this is y value for my first data points, right? X, y. So that means what's the explanation of this? You are simply multiplying x and y. That means you simply multiply these two, right? 63 times 7, how much it is? You just multiply. 441, am I right?
Sir.
Yeah. Now this one, you simply squaring the first one. So you are squaring 63. What is 63 squared? 63 squared. That is 3969, right? Now here you are squaring your y value. This is my y value, 7. 7 squared is 49. Okay. So like that, did I give the table? Yes, it is here. Right? So I have completed all the tables like that, all the table values. So look at these values now. Everything is there, right? Okay. Now, if you find the total among, right, this column, that is nothing but the summation of xy, right? You are adding all the xy's. That is the summation of xy. Simply take your calculator and add these all values. It is 682.77. Similarly, if you add for your next column, that is the summation of x squared, that is this. Then the last one, if you add all the summation the values of y squared, that is the summation of y squared, that is 80.67, right? So simply you add them. Okay. Now if you move to here, you are given your x value, simply add all the x values. So that is summation of x. This is all the y values, so it is summation of y. So I have all the summations, right? 1, 2, 3, 4, 5. Now, once you have all the summation values, go for your formula and plug in those values, right? Okay, little n is now 6. The data points, number of data points, 6. Summation xy is here. That is 682.77, plugging that value. Then you are subtracting summation x, that is where? My first column, this one, right? Summation of x. So that is 153.8. Then you are multiplying with summation of y. Y is my second column in your answer, that is 18.7. Then divide by square root. Okay, you have to be careful when you plug in the values into the denominator, please. You have so many parentheses. Make sure that you plug in the values correctly. So here to here, this all under one, the set of parentheses. So little n is 6. Summation of x squared is 5,859. That is here. Then you are minus subtracting the summation x squared. Summation x squared is again the same thing, right? So you are summation of summation x of square, I think. Yeah. So this square should be outside. Okay. So I think this should be outside. So look at that. It should be outside. Yeah. So this is the correct one. Okay. You see, there's a typo here. Do you see that typo? There are
Yeah,
typos
it's
here.
supposed to be outside the
Yeah,
parentheses.
the square should be outside of the parentheses, like that. So make sure that you are using the correct formula. That's what, if you see here, the square is outside of the parentheses. So that means you have to plug this value, then square. Similarly here, okay? Now this is the way to find the, the R. After that, you are using calculator and massive calculation, right? So use your calculator and simplify carefully. You see your R value is 0.982, very much close to 1, right? It means we had the positive 1, very close to 1. Therefore, these data values has very, very strong, positive linear relationship, okay? Because R is very close to 1. Anyway, we don't need to make this much struggle when you use the calculator. It's very, very simple, okay? Now I'm going to show you how to use the calculator, so TI-83 plus I'm using, right, to calculate little r. Okay, so what are the steps we are going to follow? First, you have to, enter all the data values, enter into L1 column and L2. Basically, our x values in L1 and y values are in L2. Okay, now move to stats. Okay, then move to calc. So let me show you. So first I need to enter all the data points. I already have entered, right? Because I'm using my previous data values. So let me show those things. You see now, I have entered all the data values. After entering all the data values, go to stat and calculate. Remember, I'm looking for the linear regression relationship. So you have to go for number 4 and enter. You see now, you see little r here. We are looking for r. So the little r value, calculated value is 0.98192. So if you round up to a 3 decimal place, exactly you are getting the, the answer whatever just now we got. You see the calculator is very easy, the way we are using. So you have to go for number 4, linear reg ax plus b. We are looking for the linear relationship, and now you will get the r. Okay. So, but let me tell one thing. When you use this first time in your calculator, sometimes the calculator will not show up this little r. Okay, is there anyone you are not getting r value in your calculator like this?
Yes, sir. I only got A and B because I got a
Exactly.
C and B
Yes,
before.
yes, that is the common thing. So you will not get a little r. So that means so you have to go and do some setup in your calculator. Okay, I will show you. Okay, so let me write that. Suppose if R is not showing up, then do the following. Okay, so go to catalog. Okay, go to catalog. So I will show you that. So go to catalog. Where's that? Catalog here. That is in zero, the zero button, right? So second with zero. So go to catalog. How do you go? Second plus zero button. Then after going to the catalog, I'll find out this one, this function, diagnostic, right? Make it on. Default one is off, so we have to make it on. So go to the catalog, second with zero. You will have a bunch of functions here. So move your cursor down all the way to the diagnostic number D, letter D. Yeah. So you have to make the diagnostic on, then enter one more time. That's it. You are done. Now go back and check the procedure. You should get a little R.
Yep,
So,
good to go.
yeah, you are getting right.
Yes, sir.
Yes, very good. So that's the way to find little R. Okay. So now, the next question is, we are finding little r. Remember, what is our actual task? Our actual task is to check whether our population correlation, coefficient is very much close to one or not. We are checking whether, the population, the, the values, the variables has a linear relationship. Instead, we are checking the sample, right? But there is no guarantee. There is no guarantee, right? For being actual correlation is this one. This is from sample, right? We got, but we don't know whether this is actually happened or by chance or by accidentally because of my data values we got 0.98, or is this true actually for my population? We don't know, right? Because these are coming from my sample. So that means my little r is now based on my sample. So you may get accidentally this value, right? Once you change your data point, you may have some different values. So that means there's no guarantee for being actual, the linear relationship between your variables. So for that reason, we are going to check whether this is actually happened. So how are we going to check? We are going to use the testing hypothesis, okay, to check whether our population correlation coefficient is zero or not. So that is next step, right? So we are going to use this testing hypothesis for what? For the population correlation coefficient. So we are using a little row, right, for population correlation coefficient, right? So my actual task is to check this guy, right? To check this one, we are using my sample correlation, right? So I'm using this sample guy to check whether this has a linear relationship. So I'm setting my hypothesis here. These are the values again. Set the hypothesis, find the critical values, complete the test value, make the decision. The same thing we follow under hypothesis testing. Okay, right. So these are the assumptions we use for the testing the significance in the sense we are checking whether my population, correlation has actually no relationship with my alternate, not zero. So these are my two hypotheses, alternate and null hypothesis. Okay. So now these are the assumptions we use. The data are quantitative and are obtained from we are using for the quantitative data. That means the numerical values, right? So the simple random sample is simple random sample. The scatter plot shows that the data approximately linear related. So the scatter plot of our data is approximately linear. There are no outliers in the data. So outliers, will make big difference. Therefore, we assume that there's no outlier in my data. If you have outliers, you have to throw those points. We don't use those, okay? the variables x and y must come from the normally distributed population. So this is a basic assumption we use. Okay. So at this course level, we assume that all the four assumptions are satisfied. So we don't go much in detail. So now these are the two hypotheses now we have. So my null hypothesis, I'm taking my population correlation is 0, right? This null hypothesis means that there is no correlation. So if rho is 0, we know there is no correlation between x and y, right? For my population, I'm checking for my population. This means what? This means there's a relationship between x and y, right? This alternate hypothesis means that there is a significant correlation between the variables in the population. So these are the two things now we are going to, set up. Okay, so now we have this, the hypothesis. The next one is what is my test statistic? My test statistic here I'm using for a t test. Okay, t statistic. So my t test value here is given by little r times square root n minus 2 over 1 minus r squared. Remember, these all values are coming from where? Your sample. Little r, right, could be calculated from your sample. Enter all the data values into your calculator and find out your little r. What is little n? Sample size, the number of data values. So if you're plugging all the values, you will get your test value, right? So you'll be given alpha in the problem, so you know the critical values of t. After that, you will check whether the t test value falling into your, the critical region or not. Based on that, you will find your decision, right? Okay. So if you do this testing hypothesis for the same example, just one we are working, right? Test the significance of the correlation coefficient found in the example 2, the one we discussed. For alpha 0.05, if you look at your hypothesis here, you see my alternate not equal sign, therefore this is a two-tail test. I'm using my t distribution, right? So my alpha is now 0.05, therefore this is alpha over 2, that is 0.025. So this also 0.025. So now use your t distribution table and find these two critical values, right? Remember, t distribution table will give you, you have to plug in, the right area to the point, and you will find out those two values as what it is given here. 2 point. You should get 2.776. Okay, that's my degrees of freedom. My degrees of freedom, little n was 6, right? Therefore, 6 minus 2, which is 4. So look at your table and make sure that you are getting these two values, right? Okay, that is my these two are going to be my critical values. Now let's look at the test value. My test value, going to use the test statistic formula, this one. So we know r little r just now we found for the previous example 0.982, right? So I'm plugging those values here to the little r, and n is 6, and again plugging r here and simplifying this number. It is 10.398. So 10.398 is far away from my critical values here. So 10 point something is here. Therefore, the test value is now falling into the rejection region, right? Therefore, you reject your null hypothesis. Okay. So you reject your null hypothesis. Reject the null hypothesis. That means what? That means we accept H1. That means what? Really, we have linear relationship, right? Among all the population, the data population values, data values. So there's a strong relationship between x and y.